Welcome to the deep dive. Ready to take a mountain of numbers and actually make sense of them?
Make sense of them.
We're cracking open chapter 11 of a research methods textbook
Ooh, textbook time.
to give you a cheat sheet on turning raw data into solid insights. Think of it like a data analysis toolkit.
Hmm.
You can use it whether you're digging into research or tackling your own projects, or even just trying to understand the world a little better.
I like that. A toolkit for the world.
Yeah.
So this chapter is really cool because it lays out these three key stages of data analysis. And the best part is these stages, they work no matter what kind of data you're dealing with.
Okay, so three stages. What's the first step in this data analysis adventure?
The first stage is all about getting to know your data.
Getting to know your data.
Yeah,
Okay.
it's kind of like detective work. You got to clean the data, look for clues, and make sure everything's in order before you can start drawing conclusions.
Cleaning the data. That sounds a bit tedious.
Oh, it can be.
Is it really that important?
It is absolutely crucial. Think about it, like you wouldn't bake a cake without checking if your ingredients were fresh.
Right, I guess not.
Same goes for data analysis.
Yeah.
We need to make sure there aren't any typos or impossible values that just don't make sense,
Hmm.
or outliers that might be skewing the results.
Outliers, those are the numbers that are technically possible, but they just make you go, wait, really? Like, if someone said they ate 50 tacos in one sitting, technically possible, but a little hard to believe.
Exactly. The chapter actually gives this example from a vocabulary study
Hmm.
where they found this participant in the older adult group who scored way higher than everyone else. It turned out to be a legitimate data point.
Oh, wow.
But it really highlights how important it is to really understand your data, not just blindly trust the numbers. Sometimes those outliers, they can point to interesting patterns or unique cases that are worth exploring further.
So it's not always a bad thing. It could be a clue.
Yeah, exactly.
Okay, so we've cleaned our data, we've investigated those suspicious outliers. What's next? How do we start making sense of this mountain of numbers?
That brings us to stage two, summarizing the data.
Summarizing the data.
This is where we start painting the big picture using those familiar descriptive statistics, like the mean, median, and mode.
Oh, yeah, I remember those.
Yeah, but the chapter goes beyond those basics. It introduces some really powerful tools that can help us understand the patterns in our data more deeply.
I remember those terms from school, but honestly, they always felt a bit abstract. Is there a way to make these concepts more concrete and relevant to someone who's not a statistician?
Absolutely. One concept I find particularly helpful is standard deviation. It tells us how spread out the data is. Are the numbers clustered closely together, or are they scattered all over the place? The chapter uses the vocabulary study again as an example. They explain that the older adults, they had a larger standard deviation than the younger group, meaning their scores were more diverse.
So a larger standard deviation means there's more variability in the data, which could point to individual differences or other factors influencing the results. That's pretty cool. Are there any other tools that can help us see the bigger picture?
Here's where it gets really interesting. Effect size.
Effect size.
The chapter explains this thing called Cohen's d. It's a measure of how big the difference between groups is,
Mm-hmm.
regardless of how many people are in each group. This means you can quickly judge how important a finding is, even if you don't understand the original measurement. The vocabulary study actually found a large effect size for age,
Meaning what?
meaning those older folks were they were winning the vocabulary game.
Winning.
Yeah, a lot.
So even if two studies use totally different ways to measure vocabulary, we could still use Cohen's d to compare their results directly and see which study found a stronger effect. That's a really powerful tool. But after all this detective work and summarizing, how do we know if our findings are rock solid or just a fluke?
Good question.
That's where stage 3 comes in, right?
Precisely. Stage three is all about confirming what the data reveal.
Okay.
And this is where confidence intervals, they take center stage. You've probably heard of margin of error in polls, right?
Yeah, it's that plus or minus range they give you, like.
That margin of error is actually a confidence interval in disguise. Instead of just saying the average we're saying we're 95% sure the true average falls within within this range.
So it's like a safety net for our findings, acknowledging that there's always some uncertainty in our data. The
Yeah.
narrower the range, the more confident we can be in our results.
Exactly. The chapter uses a study with hints and some pictures as an example. They show you the confidence intervals right on the graph, so you instantly know which age groups are truly different in their behavior.
I love a good visual, so we can actually see the range of possible values for each group and compare them side by side. The study found that 9-month-old babies grab at pictures way more than older babies, but the 15 and 19-month-olds weren't so different, and they were looking at pointing behavior too. I wonder if that changes with age as well.
That raises an important question. It might be worth digging deeper into figure 11.4 if you're curious to see how the confidence intervals for pointing behavior compare across those age groups.
I think I will. Now, before we move on, the chapter takes a little detour to talk about correlations and scatter plots.
Oh, yeah.
What makes these concepts so important for understanding data?
Well, correlations, they tell us how much two things go together, like height and shoe size,
Oh,
usually.
right, right.
And scatter plots are a fantastic way to visualize those relationships. They give us a clear picture of whether there's a positive, negative, or no relationship between the variables.
So if we plotted height and shoe size on a scatter plot, we'd probably see a pretty strong positive correlation, right? Taller people tend to have bigger feet. But the textbook mentions that we need to make sure the trend in the data is linear before we can calculate a correlation coefficient. Why is that so important?
That's a great question. It all comes down to understanding what the correlation coefficient is actually telling us. It's a measure of how well a straight line can represent the relationship between those two variables. If the relationship is curvy or more complex, then forcing a straight line through the data just won't give us an accurate picture.
So it's like trying to fit a square peg in a round hole.
Yeah.
You can force it, but it won't be a good fit. But what if we do see a clear linear trend on our scatter plot? How do we actually interpret that correlation coefficient?
The correlation coefficient,
Right.
often represented by the letter R, tells us two key things: the direction and the strength of the relationship. Remember how we talked about positive and negative correlations? A positive correlation means the variables move in the same direction, while a negative correlation means they move in opposite directions.
Right, right.
The value of R tells us how strong that relationship is. It ranges from -1 to +1,
Yeah.
with 0 meaning absolutely no relationship. The closer the value is to 1, positive or negative, the stronger the correlation.
So if we have a correlation of, say, plus zero point 0.8, that's a pretty strong positive correlation, right? It means we can be fairly confident that as one variable increases, the other tends to increase as well.
Precisely. But we have to remember that even a strong correlation doesn't mean one variable is causing the other to change.
Yeah.
There might be other factors at play that we haven't considered. It's like that classic example of ice cream sales and drowning deaths, both going up in the summer.
Right. It's not that ice cream is causing people to drown, but rather that both are influenced by a third variable, hot weather. So correlation doesn't equal causation, but it can still give us valuable insights into how variables are related.
Absolutely. And we can use correlations to make predictions about how one variable might change based on changes in the other. But we always need to be mindful of those potential third variables lurking in the background.
Okay, so we've covered a lot of ground in this first part of our deep dive. We've talked about cleaning our data, summarizing it with descriptive statistics, using confidence intervals to assess our findings, and exploring relationships with correlations and scatter plots. Where do we go from here? What other data analysis adventures await?
Well, in the next part of our deep dive, we'll delve into the fascinating world of transforming data.
Transforming data.
Yeah. It might sound intimidating, but it's a powerful technique that can help us uncover hidden patterns and make our data even more meaningful.
Transforming data. I'm intrigued. It sounds like we'll be putting on a new pair of data analysis glasses and seeing our numbers in a whole new light. I can't wait to explore that further. Stay tuned, folks. We'll be back with more data analysis insights after. Welcome back to the deep dive. Before the break, we were getting our hands dirty, cleaning data, summarizing it, and even spotting those intriguing
Yeah,
correlations.
those correlations.
It feels like we've already leveled up our data analysis skills.
For sure, for sure. And the journey continues.
It does.
Remember we talked about transforming data?
Yeah, transforming.
It's like giving our data a makeover, to reveal hidden patterns or make it easier to work with.
That's right. You mentioned it's like putting on a special pair of glasses to see things differently. Can you give us a concrete example of what a data transformation might look like in the real world?
Absolutely. Let's say you're tracking your daily exercise time for a month.
Okay, daily exercise time.
Some days you might be a real superstar hitting the gym for like 2 hours. Other days, well, maybe you just manage a brisk walk around the block.
Yeah, some days are better than others.
If you have a few of those superstar workout days, those outliers, they could skew the average, making it seem like you're exercising more than you typically do.
I see. So those outliers can create a bit of a distorted picture.
Right. But if we transform the data, maybe by taking the logarithm of each value,
The logarithm.
yeah, those outliers will have less impact, giving you a clearer picture of your typical exercise habits.
So a data transformation is like adjusting the scale to get a more accurate view. It helps us see the forest for the trees, so to speak. But how do we know what kind of transformation to use? It sounds like there are a lot of options.
There are. It could be as simple as changing inches to feet, or degrees Fahrenheit to Celsius.
Oh, okay.
But sometimes we use a more sophisticated mathematical transformation,
More sophisticated. Okay.
depending on the data and the analysis we want to do. The key is to understand your data and the statistical techniques you're using to choose the most appropriate transformation.
It sounds like we need to be pretty savvy with our math skills to pull this off. Is this something that requires a PhD in statistics, or can a regular person like me handle it?
Don't worry, you don't need to be a math whiz. Most statistical software packages these days can handle these transformations for you. Once you know what you're looking for, it's more about understanding the concept and knowing when a transformation might be helpful.
That's reassuring. It's great that we have these powerful tools available to us. So we've explored different ways to clean, summarize, visualize, and even transform our data. We're building quite the data analysis toolkit. But before we get too carried away with all these techniques, is there anything important we need to keep in mind? Any big picture ideas that can help us stay grounded as we delve deeper into this world of data?
That's a fantastic question. It's easy to get caught up in all the technical details,
Mm.
but we always need to remember that data analysis is it's ultimately about asking the right questions. It's about being curious, digging deeper, and trying to uncover the story hidden within those numbers.
The story. Okay.
Data analysis is it's more than just crunching numbers. It's about understanding what those numbers mean
Mhm.
and how they can help us understand the world around us.
I love that. It's about being a storyteller, using data as our raw material to craft a narrative that can inform, inspire, or even challenge our assumptions. But sometimes those data stories can take us down unexpected paths, can't they?
Oh, absolutely. Data analysis is it's an iterative process. You might find surprising results that lead you to re-examine your initial assumption, refine your questions, or even collect more data. It's all part of the journey of discovery.
So it's not always a straight line from data to conclusions.
Right.
It's more like a winding path with unexpected twists and turns. And sometimes we end up in a completely different place than we expected.
Yeah. Exactly, and that's what makes it so exciting. You never know what you might uncover when you dive deep into the world of data. Each analysis is a new adventure, a chance to learn something new, and see the world from a fresh perspective.
Speaking of new adventures, I'm eager to see where our data analysis journey takes us next. We've covered so much ground already, from the basics of cleaning and summarizing data to exploring relationships with correlations and scatter plots, and now we've even dipped our toes into the world of data transformations. What's next on our agenda?
Well, the final part of our deep dive will be tackling a concept that might sound intimidating at first,
Okay.
but it's a crucial tool for any data detective. Null hypothesis significance testing.
Null hypothesis significance testing. That sounds a bit daunting.
Yeah, it's a mouthful.
Can you give us a sneak peek of what we'll be exploring? Will we need our thinking caps on for this one?
You bet. It's all about testing whether the patterns we see in our data are likely due to real effects or just random chance. It's a way of making sure our findings are statistically sound, and not just flukes. Don't worry, we'll break it down step by step and show you how this powerful technique can help us confirm what the data reveal.
Okay, I'm ready to put my thinking cap on and dive into the world of null hypothesis significance testing. Stay tuned, folks, for the final part of our data analysis deep dive. Welcome back to the deep dive. We've explored so many fascinating aspects of data analysis already, from cleaning and summarizing data to uncovering hidden patterns with correlations and transformations.
Yeah, lots of tools.
Now it's time to tackle that final piece of the puzzle, something called null hypothesis significance testing. It sounds pretty intense.
It might sound intimidating, but it's really just a helpful tool for any data detective out there.
Data detective. Okay.
Null hypothesis significance testing, or NHST for short. It helps us figure out if the patterns we see in our data are they actually meaningful or just random noise.
So it's like a reality check for our findings. We're trying to make sure we're not getting excited about something that's just a fluke.
Exactly. Imagine you're flipping a coin.
Okay, flipping a coin.
If you flip it 10 times and get heads 8 times, you might think, whoa, this coin is biased. But it's possible you just got lucky with a few extra heads. NHST, it helps us determine if our results are statistically significant, meaning they're unlikely to have happened just by chance.
Okay, that makes sense. So how do we actually put this NHST idea into practice? Where do we even start?
It all begins with the null hypothesis.
That's the hypothesis.
Which is it's basically the assumption that there's no real effect going on. We pretend there's nothing interesting happening in our data.
So in the coin example, the null hypothesis would be that the coin is fair, and we're just seeing random fluctuations in heads and tails.
Precisely. Then we collect our data and see how likely it is to get those results. If the null hypothesis were true, if it turns out our results are really unlikely under that assumption of no effect, then we have evidence to reject the null hypothesis and say, hey, something interesting might be happening here.
So we're playing a bit of a statistical game. We assume nothing is going on, then see if our data can prove us wrong.
You got it. And that's where the p-value comes in.
The p-value. Okay.
It tells us how likely it is to get the results we observed, or even more extreme results if the null hypothesis were true.
So a smaller p-value means our findings are less likely due to chance and more likely that there's a real effect.
Exactly. Researchers, they typically use a p-value of less than 0.05 as a cutoff. It means there's less than a 5% chance of getting our results if the null hypothesis were true.
So if our p-value is less than 0.05, we can be more confident that our findings aren't just random noise, and there's something worth investigating further. But the chapter also mentions that NHST doesn't tell us the whole story, right?
Right. It's important to remember that statistical significance, it doesn't necessarily mean our findings are practically significant. NHST doesn't tell us how big or important an effect is,
Okay.
just that it's unlikely to be due to chance.
So a statistically significant finding might not actually be that meaningful in the real world.
Exactly. We always need to consider other factors like the effect size, the context of our research and our own judgment when interpreting our results.
It sounds like NHST is it's a powerful tool, but we need to use it wisely and not let it be the only factor driving our conclusions.
Well said. Data analysis is all about using a variety of tools and techniques to uh, to understand the story our data is telling us. It's about being curious, asking the right questions, and being open to unexpected findings.
This has been an incredible journey through the world of data analysis. We've covered so much ground from cleaning and summarizing data to exploring relationships with correlations and testing our findings with NHST. I feel like I've gained a whole new set of skills to help me navigate the world of data.
You have, and remember this deep dive has given you a solid foundation for understanding data and making sense of the numbers you encounter in your own life, whether you're reading research articles, conducting your own projects, or just trying to understand the world around you. These data analysis skills will serve you well.
It's been an eye-opening experience, and I'm feeling much more confident in my ability to make sense of data. Thank you for guiding us through this data analysis adventure, and to all our listeners out there, keep those data sets flowing and stay curious. There's always more to learn and new insights to uncover in the fascinating world of data.